So good evening. Welcome to BIOGENESIS Institute. So myself Dr. M. Keshavulu. So I am going to teach somehow physical chemistry topics regarding our notification. Right. So what are the physical chemistry topics? Right. So what are the physical chemistry topics? What parameter we are going to discuss? So then from that how the questioning will be there in the examination, previous examinations and so upcoming examination, what type of questions we will get. So and all those things will be discussed. So the base chapter of physical chemistry, that is the atomic structure. Atomic structure. Right. So in atomic structure, so there is a starting of particles, right? Dalton's theory. So may start with Dalton's theory, how the atoms are recognized, right? So what are the characteristics of atoms and what are the fundamental particles which are involved in atoms, like protons, neutrons, electrons, and the regarding protons, neutrons, electrons, various properties like charges, mass, then relative mass, right? So all those things will be discussed in atomic structure with the help of that basics only. So in our syllabus directly mentioned, right? Directly mentioned Schrodinger wave equation. As we have to understand that Schrodinger wave equation, definitely we will go through some basics only. With the help of basics, we are able to solve, understand the syllabus, what they mentioned in the examination. With the help of that, we are able to solve the questions easily, right? So then, the second one will be redox reactions. Redox reactions. Right. So the redox reactions will be mentioned oxidation states and oxidation numbers. In that particular reactions are the redox reactions. Whenever we have to understand the redox reactions, definitely we'll go with oxidations, reductions. Whenever the reaction is carried out, both oxidations and reductions are such called redox reactions. How many type of redox reactions are there? Then how we have to write, and particularly in balancing of redox reactions equation, that will be mentioned in the syllabus. Right. So then coming to the third one, thermodynamics. Right. So thermodynamics means any reaction will be carried out. So whether that reaction is a spontaneous reaction or not, particularly the nature of this spontaneity can be explained with the help of thermodynamics. Here we use it to explain all those laws. First law, zero law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and limitations of second law of thermodynamics that will be kept in third law of thermodynamics. All huge syllabus will be mentioned in detail of thermodynamics. Then how the various parameters, means conversion of energy, how heat energy is converted into other form of energies like work, internal energy, enthalpy, all those things, energy conversions will be explained in thermodynamics, right? Then coming to the part of fourth one, right, phase rule is there. Phase rule. So whenever we are going to discuss about phase rule and its applications, means any matter is existing in various forms, right? Matter will be exist in various forms like solid form, liquid state and gaseous state. Three states are there. In addition to this, some other two states also will be there. One is plasma state and other one will be Bose-Einstein states. So how the matter will be exist in the various phases, all those phases will be represented with the diagram, so that will be explained in phase rule. So here one component system will be mentioned, that is particularly water system. Water can exist in solid, liquid and as well as gases. So and two component systems also will be discussed in phase rule, right? So next, coming to the part, next one, solutions will be mentioned. Right. So solutions means, so whenever two components are mixing together, which forms solution, in which one of the component is a major component, the other component will be minor component. How they may mix together to form a solution, what are the characteristics of the solutions? Whether that solution may be ideal solution or non-ideal solution, that maybe depends on what type of laws, right? Whether here we are going to discuss about Raoult's law and as well as Henry's law, and based on that Raoult's and Henry's law, so we will get the questions in the examinations, right? So then the sixth one, So colloids and colligative properties. Colloids and colligative properties. Right. So colloids will be separate chapter will be there, and colligative properties. Whenever we are discussing about solutions, right, what are the various type of the solutions, right? True solutions will be there, colloids are there. How we are going to differentiate that solutions and colloids, and what are the properties of colloids will be there. So like leophobic colloids, right, leophilic colloids, and what is the Tyndall effect, and what is the Brownian moment, such type of topics we are going to discuss it in colloids, right? Then colligative properties means which is applicable for solutions, particularly dilute solutions. There are 4 type of colligative properties are there. One is relative lowering of vapor pressure, then elevation of boiling point, depression in freezing point, and osmotic pressure. So particularly in that topics, so there is a chance to ask the questions, right? So next one will be electrochemistry is there. Right. Electrochemistry will be particularly how the concentration will be changes. The concentration will be changes from one reactant to another products, means whenever the reaction will be taking place, how the concentration will be varying between the reactants and products. So those concentration terms will explain what kind of properties and what is the Nernst equation, how the reduction potentials and how the EMF values, all those things will be explained in electrochemistry particularly. So it will be explains about weak electrolytes. The weak electrolytes will be explained with Kohlrausch law. How the equivalence conductance of weak electrolytes can be explained with the help of Kohlrausch law. Such things will be explained in electrochemistry. Then whenever the reaction is carried out, so how much time it will take to completion of that reaction, the time dependent properties will be explained in chemical kinetics. So the time progress of reaction, so and rate of the reaction, order of the reaction, what is the molecularity of the reaction, so what are the factors which are affecting on rate of reaction, what are the units, all those things will be explained in chemical kinetics, right? So in addition to this, one catalysis topic will be there. Catalysis, right? So what is the catalysis means? Whatever is the reaction rate, we have to increase, we have to use some external substances, right? So with the help of that external substances, how the rate of the reaction will be increases. So whether with the help of catalyst, sometimes rate of the reaction also will be decreases, that we may call as negative catalyst. In which situation rate of the reaction will be increases, that we may called as a positive catalyst. So right, so for various type of the reactions like exothermic reactions and endothermic reactions, how the catalysis will be applicable for that. Then what kind of reactants are involved, whether same kind of same physical state of reactants are involved or different physical state of reactants and catalyst will be involved, based on that homogeneous catalysis, heterogeneous catalysis, and particularly catalysis means biocatalyst, nothing but enzymes. Whenever in presence of enzyme, how the reaction will be carried out, that will may gives information regarding enzymes catalysis, particularly where we have to discuss about Michaelis-Menten mechanism. So that will be follows what type of order kinetics, that is also we are going to discuss. Then coming to the last chapter, that is the photochemistry. That reactions will be carried out in the presence of light only. Particularly the reactions are carried out with the help of incident of irradiation of light radiation, right? The rate of the reaction is depends on intensity of the light only. So there are various laws is there, Grother-Draper law, Stark-Einstein's law, Frank-Condon principle. So how it will be related to that, and what is the particular term, that is a quantum yield. So such things will be discussed in photochemistry. Means the entire physical part will be, so that will be in 10 units in our syllabus. These colligative properties will be mentioned separate. So if you may consider this is separate, that are 11 topics will be there. So these all the 11 topics we are going to finish within the month of June up to June 20, right? So whatever we have time, 50 days period, in this 50 days period we are going to cover all those things, right? What they mentioned the syllabus in physical chemistry, So to understand all those concepts, so definitely required some basic concepts. What are the surrounding basic concepts to mentioned syllabus? That are also we will explain in detail with the help of basics only. So even we will get some questions from basics also. Whenever we are going to discuss about atomic structure, particularly, right, in atomic structure, so they mentioned directly what Schrodinger wave equation. Schrodinger wave equation. So how the Schrodinger wave equation will be derived, what are the consequences before getting of Schrodinger wave equation, we have to know all those things only. The base of Schrodinger wave equation is there are three laws or base laws are there. So that are one will be, right, if we have to understand the concept of Schrodinger wave equation, right, Schrodinger wave equation. What is the Schrodinger wave equation? So that is in terms of three-dimensional system, means dimensions of the system also we have to know. Whenever the particle is moving in along x dimension only, so with the help of box length, that is 0 to a, so this is the one dimensional box, right? So whenever the particle is influenced with two dimensions, x dimension and y dimension, right? So here we use it to get the particle, so that will be influenced by x and y. This is the particle. This will be treated as two-dimensional system, right? Whenever the particle is influenced by all the axes, right, x-axis, y-axis and as well as z-axis. So if you may consider any one of the axis, any one of the property, so the particle that is x comma y comma z, that is influenced with all. So this is z-axis, y-axis and x-axis. One dimensional, two dimensional and this is three dimensional is there. The Schrodinger wave equation for all this, one dimension means only we have to consider x dimension, two dimension means we have to consider x and y dimensions, three dimension means we have to consider x, y, z dimensions. With the help of consideration of all the dimensions, how we have to write that Schrodinger wave equation, right? So that Schrodinger wave equation will be dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equals to 0. This is the Schrodinger wave equation. What is the base of getting of this equation? How it will be applicable for the microparticles? Microparticles are what? Here we are going to discuss about microparticles. That microparticles, right? So the proton, neutron and electrons are the microparticles. We are going to study all those properties of protons, neutrons and electrons. We have to apply that Schrodinger wave equation. How we are getting these substances? So that means basic concept will be there. With the help of introduction, we have to understand all those properties of these particles and it will be applicable, right? How the Schrodinger wave equation will be developed, that is based on Planck's equation. Planck's equation. What is meant by Planck's equation, right? So any substance that will be going to absorb energy, right? So the absorption or emission of energy or emission of energy, that will be happened in terms of discontinuous form, right? The absorption or emission of energy in terms of discontinuous form, so in the form of small packets, each packet will be considered as quantas, right? With the help of that concept, the energy is directly proportional to nu, therefore E is equals to h nu. So this is the concept is based for getting of Schrodinger wave equation. Means we have to know or we have to discuss in detail about Planck's equation, right? So then after that, de Broglie's principle. De Broglie principle. What is meant by de Broglie principle, right? Whenever the particle which is revolving around the nucleus, for example, if you may consider atom, this is the nucleus, the electron which will be revolving around the nucleus. Two possibilities are there for revolving of electron around the nucleus. One will be clockwise, other one will be anti-clockwise. That clockwise and anti-clockwise may indicate the spin of the electron. So whenever this is revolving around the nucleus, that electron possesses dual nature. So the concept of dual nature can be explained with the help of de Broglie's principle. What is meant by dual nature? One is the wave nature, the other one is the particle nature. One is the wave nature, other one is particle nature. So with the help of this, de Broglie has given one equation. So that equation will be helpful to understand the Schrodinger wave equation. What about that de Broglie's principle? So that will be given that lambda is equals to h by p. Lambda is equals to h by p. H is a Planck's constant, p is a momentum. That momentum will be defined as h by m into c. Whether c is the velocity, m is the mass of the particle, the product of m into c will give momentum, right? So linear momentum, or else if velocity will be v, that gives mv, right? So and also it will be, this will be converted into kinetic energy. So that is h by square root of 2m into kinetic energy. This kinetic energy will be expressed in terms of electron volts, right? Charge and volts, potential and charge. Therefore that is kinetic energy will be 2m into E into V. Means how we are getting all those equations, right? So based on this dual nature, so de Broglie given this equation, Planck's given this equation, and one more principle will be there, that is Heisenberg uncertainty principle. Heisenberg uncertainty principle. What is meant by Heisenberg uncertainty principle? Right? So whenever the particle which is revolving around the nucleus, that can possess dual nature, then what about the position of the particle, and what is the momentum of particle when it is revolving around the nucleus? Means that will be going to explain two parameters. One is the position and other one is the momentum. According to classical mechanics, right, the both position and momentum of a macro particles, means large particles, can be determined simultaneously at a time. For example, I am giving, right, so you all people know, right, present IPL is going on, right? So everyone used to see the matches. Whenever a bowler throw the ball to the batsman, right, so that ball, where the position of the ball is there, and what about that speed of ball, both can be recognized. That third umpire will displace all those things, right? What about speed of the ball and where the position of the ball will be there? Means position and momentum both can be determined simultaneously. That is applicable for large particles. But in case of microparticles, for microparticles, the determination of position and momentum simultaneously, it is impossible. It is not possible. If we are going to measure the position accurately, at the time momentum will be uncertain. That becomes infinity. We cannot determine. If we have to determine the position, the momentum will be uncertain. Or if we determine the momentum, position will be uncertain. So based on that momentum and position, the Heisenberg will be given. This is the uncertainty in position delta x, uncertainty in momentum, that is delta p, that is equal to or greater than to the h by 2 pi. So these are the three principles, 1, 2 and 3, that are Planck's equation, de Broglie's principle and Heisenberg uncertainty principle. These are helpful to get the Schrodinger wave equation. This Schrodinger wave equation is applicable for 3-dimensional, 2-dimensional and 1-dimensional. From that we are going to getting the various properties of microparticles. So that will be mentioned in the atomic structure. So whatever they mentioned, so before that what are the concepts are helpful to understand that one. Then from that what we are getting the information, right, with the help of that it will be easy to understand the equations mentioned in the syllabus, right? So this is the one kind of, means how we are going to introduce Schrodinger wave equation. Whatever is the topic, that will be mentioned in the syllabus. We have to introduce like that only, means with the help of basics, what are the surrounding basics towards it, then how we have to understand that mentioned syllabus, right? So then how we have to crack good score in the examination within the span of a small period of time. So definitely we able to know. So whenever it is required, we will give in detail. So and also short form also we will provide it to that. So definitely we will go with short form. We will do the questions, right, that particularly helpful in mathematical equations, by solving of mathematical equations, right? So like similarly, so like many topics will be there. If we use it to consider one more topic, right, how we are going to discuss about all those mentioned syllabus in that particular topic. So if we take thermodynamics, right, so there is a mention in detail clearly, right? So from system onwards it's there some terminology which will be involved in this thermodynamics, right? So what are the terminology is involved in this thermodynamics? That is, one is the system, then the other one is surroundings, then the third one is boundary surface, right? So three terms will be there. If you understand these three terms clearly, so therefore we will understand the further topics easily with the help of these, right? So simple thing, I am going to understand this concept like system, surrounding and boundary surface. So just use this board. This is the board, is the universe, right? In this entire board I am going to select some particular portion only. This is the portion which is under my observation. So only I have selected some little bit portion that is under my observation, that is called system. Any specified portion which is under our observation or which is under our study, that is called system. So I have selected only this area. The remaining part of this board will be treated as what? Surroundings, right? So the remaining part will be treated as surroundings. The area which divides system and surroundings, that is called boundary surface. Whatever the topics will be mentioned in the thermodynamics, that all will be related to this. What will happen means particularly transformation of or conversion of heat into other form of energies we are going to discuss in thermodynamics. How the heat energy will be exchanged between the system. Sometimes the system will be absorbs heat energy from the surroundings, right? So at that time work done on the system will be taking place. The work done on the system, arrow marks towards to the system means work done on the system. Then the arrow mark will be indicating this towards the surroundings means work done by the system. Terminology is very important. With the help of this terminology we will understand whatever the topics mentioned in the thermodynamics, what we are going to discuss. So here we are going to discuss 4 thermodynamic laws, right? So what are those? The first one is zeroth law of thermodynamics. Zeroth law of thermodynamics, right? Then first law of thermodynamics, then second law of thermodynamics, then third law of thermodynamics. What are those laws? How they may mentioned? So that laws will be understood with the help of this basic terminology which will be involved in that. Here we are going to say that, right, heat will be exchanged between the system and surroundings. If whenever system and surroundings temperature will be same, for example we may consider surroundings temperature will be 25 degrees centigrade, even system also is present at 25 degrees centigrade. Both surroundings and system temperature will be present in same temperature, means they are present in equilibrium. Such equilibrium we may call as thermal equilibrium. Therefore the zeroth law of thermodynamics is going to explain about thermal equilibrium between the system and surroundings. This will be simply explains, right, how one system is thermally equilibrium with other system, the same system again thermally equilibrium with another system. Means system A is thermally equilibrium with system B, system A is thermally equilibrium with system C. There is no direct contact between them, B and C, but with respect to A, both these B and C also thermally equilibrium with each other. So what I mentioned, that condition of thermal equilibrium, right? So thermal equilibrium means maintaining same temperature. For example, this is the 25 degree centigrade A, therefore B also at 25 degree centigrade. Whenever A at 25 degree centigrade, C also at 25 degree centigrade. See, both B and C are also present at same temperature or not? Hence, this B and C are also thermally equilibrium with each other. This is the zeroth law of thermodynamics. Right? So, simple thing, first law of thermodynamics. How we are going to explain about first law of thermodynamics? Right? So, this is the law of conservation of mass. That means the energy neither be created nor destroyed, but it can changes from one form to another form. Energy cannot be created, cannot be destroyed, but that can changes from one form to another form. But one more statement is there for first law of thermodynamics. So that is called mathematical form of first law of thermodynamics. Whenever system is there, right? So simple we will explain. Right, here system is there. This is a specified portion that is called system. The system is going to absorb some amount of heat energy. Heat energy will be denoted with Q. So what is the definition of heat and work? All those things will be explained in detail. Right. So heat energy is absorbed by the system. That system is going to do work. That system is going to do work. The rest of the energy will be stored in the system, that is in the form of internal energy. This internal energy will be denoted with E. Right. So with the help of internal energy, so this internal energy is equals to the sum of how much amount of it is absorbed by the system and what is the work done. Therefore, hence the mathematical equation of first law of thermodynamics can be written as dq is equals to q plus w. This is the mathematical form of first law of thermodynamics. So there are various statements, sentences will be there, but with the help of the simple picture, we have to understand the concept easily. Here Q is observed, arrow marks is towards to the system means Q is observed. So from system, there is a work done. So the remaining will be in the form of internal energy. This internal energy is equals to the sum of Q and W. That is called first law of thermodynamics. Right? So, but there is no any discussion about regarding spontaneous nature in first law of thermodynamics. Therefore, the concept of spontaneity can be explained with the help of second law of thermodynamics by introducing one new concept that is called entropy. Right? So, in second law of thermodynamics, we have to introduce entropy concept. What is meant by entropy? How the entropy will be changes for the various circumstances, like whenever mixing of ideal gases will be there, how the entropy will be changing for those mixing of ideal gases. Then entropy changes during a chemical reaction, or else one phase is converted to the other phase. Between the phases, one phase is converted to other phase, right? So what will be the change of entropy? With respect to that, we will get huge information with the help of concept of entropy. With the help of that, we are going to say whether the process is a spontaneous process or not with the help of second law of thermodynamics, simply with one relation, right? So with the help of concept of entropy, we are going to say the change of entropy delta S is greater than or is equals to 0, right? Delta S is greater than or is equals to 0. That greater than symbol, delta S is greater than 0, that means positive. That will explains about the spontaneous nature of the system. When delta S is equals to 0, which explains about equilibrium, the system equilibrium, right? Equilibrium or reversible nature. All the spontaneous reactions are what? Irreversible reactions. Equilibrium reactions are reversible reaction. Whenever the delta S will be less than 0, that becomes non-spontaneous process. So means the criteria of spontaneity can be explained with the help of second law of thermodynamics. That second law of thermodynamics will be introducing concept of entropy. How we are going to introduce the concept of entropy? With the help of Carnot cycle. Whenever the process is carried out in a cyclic manner, so at that time we will get the entropy. Simple definition of entropy we are going to discuss. So that is the measurement of disorderness of the system. Measurement of disorderness of the system. measurement of disorders of the system. So for example, here we are going to see disorderness will be, right, if it is a solid is converted to liquid. Solid is converted to liquid. What about disorderness? Liquid is converted to gas. What about disorderness? As we know that solids are perfectly ordered materials. Solids are perfectly ordered materials, right? So therefore, when solid is converted to the liquid means the orderness is disappears. Liquids are converted to gases. Gases are random molecules which will be distributed in a container, right? Whenever solid is converted to the gas, what about temperature? The temperature we have to rise. By rising the temperature, solid will be converted to liquid. Liquids are converted to gases, right? Temperature will be increases. When temperature increases, what about orderness? Orderness will be, solids are perfect ordered materials. The orderness will be what? Decreases. When orderness is decreases, what about disorderness? Disorderness is increases. Disorderness is increases. When disorderness is increases, therefore entropy also increases. That entropy will be indicated with S. Therefore entropy is a measurement of disorderness of the system. So that will explains in second law of thermodynamics. But entropy is not sufficient to explain all kind of reactions, right? So that are depending on temperature also, right? So therefore, by introducing some more new parameters like Gibbs free energy and Helmholtz energy function, whatever is the reaction is there, that will be either spontaneous reaction or not. That can be explained with the help of delta G and delta A. Gibbs free energy and Helmholtz energy function. Then coming to the part, so therefore hence entropy has some limitations. That limitations are kept in third law of thermodynamics. Means we are going to discuss in detail the entire chapter with the help of basics. That will be huge beneficial to understand the syllabus what we mentioned in the examination, right? So from that what kind of questions we are getting, so we will focusing on all those type of questions. Like that all the information, some basic converts, the related to all, right? So will be explained in detail in our coaching period, right? So like that, if you may take any one topic, means remaining other topics will be there, right? Here one more topic will be there in particularly in thermodynamics, right? So just simply I will explain. So three diagrams, right? One will be exothermic reaction, one will be endothermic reaction, and other will be in the presence of catalyst. What will happen, right? So the types of reactions means exothermic reactions, exothermic reactions. The other will be endothermic reactions, endothermic reactions. Then next one will be in the presence of catalyst. Because catalysis is there, what was the role of the catalyst also we have to discuss, right? So whenever we go through the reactions, what are exothermic reactions, what are endothermic reactions, and what is the effect of catalyst in reactions, right? Simply, so we will go with the diagrams, right? So here exothermic reactions, just keep it in mind, the change of enthalpy, the change of enthalpy H becomes negative, right? So endothermic reaction delta H will be positive. So these terminology too we have to remember. When delta H is negative, what is meant by delta H for a general reaction, right? So for a general reaction I am going to write here, right? Reactants are converted to products. The delta H means change of enthalpy, that becomes enthalpy of products minus enthalpy of reactants. Enthalpy of reactants. Simple, products minus reactants means when we get a negative value means reactant enthalpy will be more, means energy of reactants will be more, at that time we will get negative, right? So these are the reactant molecules. These reactant molecules are converted to the less energetic products, right? If you may consider the delta H, right? So therefore here energy of H of reactants will be more H of products, hence delta H will be negative. Therefore such reaction is known as what? Exothermic reaction. So whatever this intensity will be there, so this is the potential energy and these are the reaction coordinates, reaction coordinates, right? So then here this will be activation energy. So this will be denoted as activation energy EA, right? So therefore this is the delta H. Coming to the part of endothermic reactions, right? So what are endothermic reactions? Means delta H is positive. When delta H is positive, we are getting means product of enthalpy will be more compared to reactants, right? So just we will go through this, right? So here potential energy, right? Or else energy, right? Energy, then reaction coordinates. Reaction coordinates, here we use it to the reactants, then the product energy will be more. This is the product, right? So therefore what is the activation energy means that we will consider for reactant activation energy. That is the activation energy. Whenever product energy will be more, therefore what we are getting, delta H is equals to H of products minus H of reactants. H of products minus H of reactants. Therefore this becomes getting positive. Delta H is positive means when H of products will be more compared to H of reactants. This is the some kind of type of reactions means. So whatever is the topic will be there. Why I am explaining like this means the topic we have to understand, particularly in physical chemistry we have to understand the topic either with the help of diagram or with the help of equation. What I have mentioned 10 topics or 11 topics in our syllabus, that in 11 topics what the topics are included in that, so that all I am going to explain with the help of diagrammic manner or with the help of equation manner. So because statements are won't remember for long period of time easily. Whenever statement will be given, so that may not remember for long period of time, so we got confusion. But when we have to study with the help of equation, with the help of diagrammic manner, so therefore we have to understand easily. What the difference of others and our institute means, we are going to give clear cut picture how to understand some basic level to syllabus level. So once you understand the content properly, it is used to solve the questions regarding that. So we are able to conduct various examinations. So as you attempt that various examinations, from that we will get some concept where you are doing mistakes, you have to identify, then go back and you have to read again and again the topics, then you will rectify that mistakes, definitely you will get your goal, right? So then coming to the part of catalyst, right? So what was the catalyst means? So here in the absence of catalyst, right, energy, then reaction coordinates. Any one of the reaction we may consider either exothermic reaction or endothermic reaction. I am going to consider endothermic reaction, right? So this is the endothermic reaction, reactants, and this is the products, reactants and products, right? So this is the happen in the absence of catalyst. In the absence of catalyst, there is no catalyst is there, therefore this is the activation energy. This is the activation energy. That activation energy will be reduced with the help of catalyst, right? So that means whatever the activation energy we are getting without catalyst, with the help of catalyst we are going to reducing this activation energy. We are going to reducing this activation energy, means rate of the reaction will be increases. The reaction will be carried out within less time as compared to without catalyst. So therefore this is indicates in the presence of catalyst. Presence of catalyst. In the absence of catalyst and presence of catalyst, how the rate of the reaction will be vary. So such things will be explained. Means each one topic, either that may be in that particular topic or else in some other topic, how those topics will be correlating with each other. So what is the correlation part, how it will be helpful to understand from one topic to other topic. So like such things we are going to explain, right? So and particularly we are going to discuss about solution part, right? So one more part I may consider how we are going to cover all those things, then how we will get the information for those topics in easy manner, so that we will observe, right? So as you go through our classes, definitely you will get easily subject, right? So as you follow regularly, right, so definitely you will get good subject. So we will provide assurance for that, right? So because we are teaching since so many years for even CSR standard, right? So these are basic concept only there. Definitely we will provide. So what are the basic concepts before that, how to understand the mentioned syllabus, and even behind it will be related to any other topics. Even those topics also we have to cover. So won't miss the question from that areas, right? So one more topic we are going to discuss, solutions, right? So I said that solutions means by mixing of two components, right? So by mixing of one component is a solvent, the other component is a solute. One component is a solvent, other component is a solute. Whenever solvent is mixed with a solute, that can form a solution. So that is called solution, right? So which one is solvent means the major component which is present in the solution is called solvent. The minor component which will be present in the solution is called solute, right? So any solution is there. For example, we know that water is a solution or not, right? Water is a solution, right? Water. What is the concentration of water? Concentration of water, right? What is the concentration of water? Means as we have to know the concentration term, we have to understand the concept of solutions. That concentration terms, any concentration term, many concentration terms there. So just I am going to give some list, right? So with the help of this, we have to understand the concentration, right? So the first one will be weight by weight percentage. The concentration term will be explained in terms of weight by weight, right? Or else explains in terms of weight by volume, right? So explains in terms of volume by volume percentage. Explains in terms of molarity. Molarity, that is M. Explains in terms of normality. Normality, N. Explains in terms of molality. Molality, that is small m. Explains in terms of mole fraction. Mole fraction, that is X. Explains in terms of ppm, parts per million. Explains in terms of solubility. Solubility. There are various number of terms are there to express the concentration, but how we are going to express the concentration means this all will be depends on amount of solute only. All the concentration terms will be explained with the help of how much amount of solute is present in a solution. Whatever is the minor component is there in a solution, with respect to that we are going to discuss all those things. As we understand the concept of all those things, what we are going to learn means whether the solution is formed, that solution becomes ideal solution or not. So what are the conditions are required for ideal solutions, right? The conditions which are required for ideal solutions. We are preparing one solution by adding solvent with a solute that can give a solution. Is that particular solution is becomes ideal solution or not, right? So what are the conditions it should be follows? So there is a mention particularly to become to get ideal behavior of solutions, that is Raoult's law. Raoult's law. We have to discuss in detail about Raoult's law, how it will be applicable for solutions, how the solution obeys Raoult's law becomes said that ideal solutions. What is the concept of non-ideal solutions? Non-ideal solutions, right? Non-ideal solutions. So these are deviating from Raoult's law. There is a deviation from Raoult's law, right? There is a deviation from Raoult's law. Why I am going to tell this means, you people be like ideal but not non-ideal. You won't deviate by saying many institutes are giving, right, coaching in this period of time, right? So you people don't attract what they are providing in terms of fare, right? So means they are providing in less amount. So what they are giving, right? So just you go through is where you will be gets more benefited. So once I am going to say, so you may think about, right, so fare related matter. If you once miss the notification, So if next notification we don't know when it will come, whether your age is applicable for that or not, we don't know. So all other factors may affected. So in front of you one notification is there, you have to treat this is the last notification to me, so I have to crack that notification. For that what I have to do, what are the resources I have, which one is the best resource to get our goal, right? You have to analysis, and so based on that, where you are getting more benefited, where you are getting particularly good subject, so you move on to this. Definitely biogenesis will offer good subjects to you, because there is a small time, right? Hardly around 2 months time is there, right? In these 2 months, if one faculty can cover all those topics, means how much time will be spent? Just you analysis, right? The same thing, we people are together 4 members or 5 members, right? We are divided the topics individually, and we are giving continuous topic individually. So those are well and expert in this subject, so they will give better subject to you, right? Continuous classes we are getting. You don't think some 1 year period is there or 6 months period is there, so we will slowly learn. No, a small period of time is there. So when within this span, how much you get benefited, right? So with the help of subject, so definitely will provide good subjects to you, right? You people be ideal, not non-ideal. Non-ideal means there are so much of deviations or occurs. So by adjacent your friend, you may say, so this is the institute is the best, these are providing with less price. So you don't think that. So trust yourself first, then others. What is on your mind? Trust means, so where you got more benefited, where you get good subject, so then you have to follow like that, right? Definitely we are the people in overall Hyderabad region will providing good subjects related to chemistry only, right? Chemistry related, so we proudly say we are giving better subjects to you, so from that you will get benefited. You be ideal and choose ideal institution and choose ideal subject and get your success, right? So this is the thing. So like this in detail we are going to discuss about all the topics within span of time. So please go through all these, right? If you have any queries, you may contact our institute, and so we'll join, and definitely you will be benefited. We will show at the final after result how much will be benefited from our institute. So definitely, so we will provide a big number, so as you put effort similar to our efforts, right? Thank you.